Hello. In this session, we're going to be talking about the little man computer and the instruction fetch and execute cycle for the little man computer. So the little man computer is a model for computation that was developed by Dr. Stuart Madnick at MIT in 1965. And it's actually still very relevant today because it allows us to simplify the way computer systems actually execute programs and understand that. So here is the model for the little man computer. The little man computer takes input and output from the user in the form of in and out baskets. There's a calculator, or an ALU, an arithmetic and logic unit, that allows us to add, subtract, multiply, and divide numbers. And these numbers are only integers, no floating point representations in this simple model. It has memory, which is a set of mailboxes. Each mailbox has a mailbox number that's associated with it, and then some data that's in the mailbox. This memory holds both the programs and the data that the programs manipulate. And it also has what's called a program counter. That is the address or mailbox of the next instruction in memory that will be executed. And finally, it has a control unit, that is the little man himself, that coordinates among all the other components. So the little man will walk back and forth between input and memory and the ALU and the program counter. The little man executes instructions that are stored in memory, and just like everything else, those instructions are encoded. So an instruction consists of an instruction opcode and a mailbox address or an operand that's in that mailbox. So just remember that these are just numbers that are in the field representing something to do and what to do it on. So here are the codes and the mnemonics for programming the little man computer. So the first instruction has opcode 5, and this allows us to load something from memory into the calculator. Store, which allows us to take something from the calculator and put it into a mailbox value. Add, which takes something from memory and adds it into the current value of the calculator. Subtract, which does the same for subtract. There would also be multiply and divide. We also have input and output instructions that allow us to read data from the user, from the inbox, or produce output to the user in the outbox. There's the halt instruction that stops the little man from executing. We have branches that allow us to change what the next instruction is that we can execute. Those are branch on 0 and branch on positive, and then an unconditional branch. And these are executed by looking at the value that's currently stored in the calculator. If it's 0 or positive, we can do one thing, or we can jump unconditionally. And finally, we have the DAT mnemonic, which allows us to store particular values in memory from the beginning. So, the execute cycle of the little man computer consists of a fetch portion and then an execution portion. In the fetch portion, the little man will look at the instruction counter, and then he'll walk over to the mailboxes and retrieve the instruction from the mailbox that was indicated by the instruction counter. The little man then increments the instruction counter so that we are set up to run the next instruction the next time. That's the fetch cycle. Now we know what instruction to execute. So the execute portion performs the instruction that was retrieved from the previous step. So here's an example program. This reads two numbers, adds them together, and then outputs the result. So I'm going to put up a simplified version of the little man computer up here. So we have a calculator, that's the ALU, we have memory, we have input, output, we have a program counter. So let's look at that first instruction there. The program counter is at instruction 1, which means that we're going to go to mailbox 1 and we're going to look at what's there. We find the code 901. Now it turns out that 901 is an input command. So we take the number 23 from input and we put it into the calculator. So we'll execute that. There's the number 23 now that's in the ALU. Notice that the program counter has updated to point to instruction 2. In there we find 307, which is to store the number in address 7. So we look at the 23 that's in the ALU and we put it into location 7 in memory. So let's do that. Now we're going to look at the next instruction, 901. 901 indicates another input. We have input there, it's the number 19, so we're going to put 19 into the ALU. The next instruction is 107, and 107 says that we're going to add, instruction 1 is add, whatever's at address 7 into the calculator. Well, what we find at address 7 is the number 23 that we just stored there from input. So we add the 23 to the 19, and what we get is an ALU value of 42. We look at the next instruction, which is 902. That's an output command, and so we take the number 42 from the ALU and we copy it into the outbox. And then we execute the halt instruction, which is all zeros, which causes our little man computer to stop executing. So in summary, the little man computer is a model for computation that's based on real-world principles. It is a model, but this is the way computers work on the internals. Instructions consist of an operation and, optionally, an operand on which to act, which is usually another memory address. We have a very simple fetch and execute cycle that allows us to retrieve the instruction indicated by the program counter, we increment the program counter, and then we execute the instructions. We have many different operations to choose from, including load, store, add, subtract, input, output, and branching.